The focus of today's notes are going to be on geography. Now, geography is really kind of the basis of the entire class. The class is called Global Studies, but that's really just kind of a fancy word for geography. Today, we're going to be focusing on what geography is, and then we're going to be looking at maps, including how to use them and a few different types of maps. Okay, so geography, as you can see, I have a definition for you right here up on top. And geography is the study of human and non-human features of the earth. Now, this is a definition that your book gives you, but what does this really mean? If you think about all the things that are human on earth, and then all the things that are non-human on earth, obviously that adds up to absolutely everything on earth. It's the same thing as if I say, look in your room, look at all the orange things and all the non-orange things. That includes absolutely everything in your room. Okay, so there are two questions that really are important in the study of geography, and they're also right here on your slide here. And the first one is, where are things located? This one's simple. Where is it? Okay, is it down the road? Is it in Minneapolis? Is it next to a McDonald's? This is the portion where we're really looking at maps. We are going to be looking today at where things are. For the rest of the semester, we're going to be looking at why are they there? That's the second question. Why are they there? And so what you have to do to figure that out is ask all of the right questions. You need to know about every part of a place to really know why it's located in the area it is. You have to think about, why did my parents choose to live at the house that I live at? Well, there could be a bunch of different answers for that, but those are the answers we have to get to be able to understand the geography of it. Or why is that restaurant located on that busy street? Okay, some things are a little more obvious, some things are a little more difficult to figure out. Okay, so we'll be studying these two questions and how we truly answer them. Okay, so now moving on, let's start with that first question. Where are things located? And that's kind of the topic of this whole slideshow. And so the first thing that we're going to look at is your directions. Okay, so we've all heard these directions before: north, south, east, west. And so it's really important to understand where those are so that you can know where something is located relative to another thing on the earth. So you can know that Minnesota is north of Iowa. Okay, and so the directions that I just said are called the cardinal directions: north, south, east, and west. And if you know where north is, if you can figure out where north is, you can always figure out where everything else is, because they're exactly 90 degrees from each other. You can see north down to here, 90 degrees. They're exactly 90 degrees from each other, and they go in the same order every single time. So if you're going clockwise, which is the same way a clock goes as moving around, okay, if you're going clockwise, then and you start at N, it will always go N, E, S, W. That is north, east, south, west. But there's also a bunch of other ways of memorizing this and understanding it, a lot of tricks to it. And so the one that I learned when I was in school was to never eat soggy waffles. And if you remember never eat soggy waffles, then you also remember what order these cardinal directions go in if you move like a clock moves, around the way that a clock moves. The other one that a lot of my students have liked in the past that they told me about probably 2 or 3 years ago is never, so I'll switch to a different pen, never ever smoke weed. Okay, and so never ever smoke weed. It's a good message for your life, but it also shows you exactly where north, east, south, and west are, as long as you're moving clockwise the way that a clock would move. And so it's really important to understand where these cardinal directions are, because if north is pointing up, like most maps are, it will look completely different than a map in which north is pointing down on your paper. It'll completely flip it upside down. So it's very important to locate this, which is called a compass rose, and see where north, east, south, and west are. The next thing that we'll talk about is latitude and longitude, which are imaginary lines that show us exactly where we are on Earth. Latitude and longitude are, as it says on here, a grid of lines that help us tell each other the location of different things on the world. This is how your GPS on your phone works. This is how you can set up and see where something is on a map. There's all of these different applications for latitude and longitude, but it's kind of one of the trickier things that we learned this year. Okay, so this grid of lines, if it's a grid of lines, if you look towards the top of the slide here, it's going to look kind of like this. It'll have lines going sideways and then lines going up and down, and now you can see that grid starting to form, almost like tic-tac-toe or something like that. And there are the lines that are going across are named something different than the lines that are going up and down. Okay, and the lines that are going from side to side are called latitude. And your book tries to tell you that latitude, the best way to remember this is that it's like a ladder, like the rungs on a ladder. Okay, but that is what latitude lines look like. And so they are obviously parallel. They run at the same distance from each other. They never run into each other or anything like that. Okay, and they're imaginary lines that run from side to side. The way that I like to remember this, the way that I learned it in school, was that lat is flat. The lines that are latitude are flat. Okay, and so if that helps you remember it, use that, try and remember that. Now, longitude is the exact opposite. Pretty simple now, right? Okay, longitude, the book tries to tell you that they should look like telephone poles. So they're up and down, up and down, up and down. Okay, and they're lines that run all the way from the North Pole to the South Pole. They touch both poles, and they go from the top of the Earth to the bottom of the Earth. So they run up and down instead of side to side. This is basically what it is. Now, there are very special lines for both latitude and longitude, and the special ones for latitude are the equator, which is at 0 degrees, and so everything is measured from the equator, which is kind of like a belt that runs right around the center of the Earth. Okay, and then there's also these two tropic lines, which we'll talk about later when we talk about the Earth. Okay, the longitude lines are, the one special one is the prime meridian. Okay, and the prime meridian is 0 degrees, and you run, or you measure the number in distance from the prime meridian, distance away from the prime meridian. So I'll continue to try to explain latitude and longitude here. I think this diagram is really pretty good, and so let's look first at the latitude part. Okay, and latitude is measured in distance from the equator. Okay, so the equator, remember that special line I talked about is right here, and that is 0 degrees. Okay, and so as if you were in math class, as you're looking at it, as you go up, you would think you'd be going positive, and as you go down, you'd be going more into the negative. That's not how latitude and longitude work, and that is where it gets really, really tricky. Okay, so if you're above the equator, it's true that as you're going up, the numbers are also going up. You can see it goes from 30 to 60 to 90, which is the absolute most you can possibly get for latitude. Okay, and so as you're looking at this, if I look at 30 degrees in the blue area, that would be listed as 30 degrees north. Okay, because it's on the north side, and it's 30 degrees away from the equator. Okay, the part where it gets tricky is when you go into the south, because you would expect it to go -30, -60, -90, but it doesn't do that. That's not how it works. Instead, since it's measuring distance, it's always positive, whether it's in the south or the north. So if we go down along this edge, then you're going to see the numbers still go up as you go further and further away from the equator, but it will just be listed in a different way. If we want to look at 30 again, over here we'll see that you would write it like this: 30 degrees, and then you would put south in there. Okay, and so that's how latitude works. It's measured in distance away from the equator. Longitude works in much the same way. It's measured in distance away from the prime meridian. Okay, and so as you move to the right, which in math class would be positive, it goes up 30, 60, 90, 120, 150 until you hit the other side of the world, which is 180 degrees away. Okay, now if you are moving to the left, which in math class would be negative, then you're looking at also going up 30, 60, 90, 120, 150, 180, which makes sense now that we understand how latitude and longitude works, because it's distance away from the prime meridian. So let's look at that same, well, let's switch it. Instead of doing 30, let's do 120. So how would I write 120 on the blue side, on the east side? I would write 120 degrees east. Okay, and then over on this side, if I did it on the red for a 120, then I wouldn't write -120 degrees east. It would be 120 degrees west. And so that's how you denote it. The reason for that, remember, is because you're not measuring like on a number line or something like that. You're measuring the total distance in degrees from the equator if it's latitude, and from the prime meridian if it's longitude. To better understand latitude and longitude, we want to look at a map to understand it on a map. And so if we look at this whole map of the world and we draw in those special imaginary lines, which for latitude is the equator, which is 0 degrees latitude, and then for longitude is the prime meridian, which is 0 degrees longitude. Now we've got the world split up into 4 different sections. And so where you are, which section you're in, is going to kind of tell you how you need to measure latitude and longitude. So if you're in Russia over here, then everything is great. If this is you, if this is where you're trying to find your latitude and longitude, that's wonderful, it's awesome. Okay, and so because as you're looking at it, first thing you need to find is your latitude. Okay, and latitude, we need to look right or at that dot, we need to find where it is, and we need to move up, 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 and it looks like the latitude is right around here. Okay, and so you can, if you can't see it, this right here is 60 degrees latitude, and this one is 75. So it's about a third of the way up, so I think we can say it's probably about 65 degrees north. So 65 degrees north. Okay, now we need to figure out the longitude, which as you move right, the values are going to go up. Okay, so let's start at the prime meridian. And let's move out, 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 out. And it looks like if we drew a line, it would be, this dot would be just about right up here. Okay, and so this one, if you can't see it because it's a little blurry, is going to be 90, and this one is going to be 105. And so if it's about halfway in there, we can guess it at about, 97 degrees would be close enough. And so we're going to then do 97 degrees and it's going to be degrees east because we are east of the prime meridian. We have moved to the east. Okay. Now, for the same exact thing, if we want to find a spot down in Australia, it's going to work a little bit differently. So let's make a dot down in Australia. How about right here? Real simple. Okay. And so what we need to do, or what we're finding here, is that as we're moving down from the equator, we're right on this line. And so being right on that line makes it really, really easy to say, okay, that's 30 degrees, and we know that it's south of the equator, and so we do 30 degrees south. Okay, and then we're going to move again, starting at 0, and move along this line, along this line, along this line, along this line. Okay, it looks like it's about right there, which this line, if we go all the way up, is 120, and this one is 135. Okay, so it's about a third of the way there. So let's say it's 125 degrees, and again, east of the equator, so it's east. Okay, now let's move into this third section, into South America, and let's put our dot somewhere in Argentina. Okay, so let's put our dot right here. Okay, and this one's going to be double tricky. This is probably the hardest section to be in, the hardest quadrant, because we have to start again at 0, and we move down, 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 and the spot is right here. Okay, so if we're moving down and we're seeing that, okay, 0 starts right here, and then 15 degrees is here, and then 20 degrees is here, and, or sorry, 30 degrees is there, and 45 degrees is here. Well, we know it's between 30 and 45. What a lot of students will do, and the trap I don't want you to get stuck into, is start at 30 and then it's down below 30, and so a lot of students will start taking away from 30. But you're getting further away from the equator, so the distance is getting larger. So if you just pay attention to the two numbers that it's between, which are 30 and 45, then you can see that really the right answer is about 37 degrees south, because we start here, we move down, 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 37 degrees. Okay. All right. Now, the other part that we have to think is now we got to move into to the west. So we don't start at the edge of the paper. We start in the middle. Okay, we start at the prime meridian and we move across, 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 and then this is the location. So really we're thinking, okay, here's 15, here's 30, here's 45, here's 60, and then the next one is 75. Okay, it's right between 60 and 75, so again, we're going to say about 67 is going to be good enough. Your estimate is going to have to be there for a lot of these questions. You're not going to have an exact number. Okay, I'll give you a little window to be able to get them right. Okay, so we will say that that one is 67 degrees west. Now again, the trap that a lot of students get into is they find this line and they say, okay, this line is 60. Okay, well, it's to the left of this line. We know on a number line, if we go left, a number goes down, it must be less than 60. But that's not how it works in latitude and longitude. You're moving further away. You're measuring that distance and you're moving further away from the prime meridian, and so that number is actually going up, which is also the way that it works in the United States. So let's go to that last quadrant, and in the last quadrant, the latitude works in the way you would expect it to. Okay, so I'm going to find it, or I'm going to make a dot up there for us to figure out. Okay, we'll put it right here in Texas. Okay, now the latitude works the way you want it to, so I made the latitude really easy. I put it right on a line. Okay, and so by now you already know that you're moving up, and the latitude you do first, and you do it right here. Okay, and so that's 30 degrees. So latitude is going to be 30 degrees, and since it's north of the equator, north. Okay, Now, remember the western one, the west works in the opposite way of the way that you would think. Okay, so we're going to go ahead and start at the very top of the page in the prime meridian, and we're going to move across, across, across till we're in the right spot. Okay, the right spot is right around there. Okay, so it's in between 90 and 105. So we're going to say it's 97 degrees, and this time it's west. Okay, and so hopefully we figured this out, and hopefully you understand it. We're going to do a little bit of practice on the next slide and see how you do. Use this map to answer questions 1 through 6 on your notes. The Earth is a sphere, and a sphere is a three-dimensional circular object. Okay, and so a three-dimensional circular object, some that you definitely know about are things like basketballs and soccer balls. Okay, it's just a big round object. All right, and the Earth is like a really, really huge soccer ball, a really, really huge basketball. Okay, and so the best way to figure out or to look at something and for the humans to display what the Earth looks like on a smaller scale is to make another sphere. All right, and so the best and most accurate way to lay out the Earth is on a globe. And a globe is just a small model of the Earth. There's one in my classroom. You've seen them all over the place. We've worked with them before. All right, so the globe is the best way, but the problem with the globe is it's really hard to tell how to get from your house to my house on a globe. Because if you look at it, the entire country of America is just a small size, like the size of a cracker, a couple of saltines or something like that. So how are you possibly going to see the little roads that get from one place in one city to another place in that same exact city? It's really hard. You can't have that level of detail on a globe. Okay, and so we've tried to find other ways to show it. Okay, well, some other ways are through photos, and I've included an aerial photo so that you can kind of see what it is. This is an aerial photo here of my hometown of Battle Lake, and an aerial photo is just a photo that was taken from an airplane. Okay, we also have satellites up in space that are constantly taking photos of the Earth. Okay, and so we can really take these satellite images and we can get really, really detailed, down to seeing a fly on the ground pictures of the Earth from these amazing cameras that they have on the satellites. Okay, and so those are really, really good ways of getting to see what the Earth actually looks like. Now, the GIS, I'm going to go ahead and skip because there's a video up in the corner that you can watch about the GIS. But maps is the last one I want to talk about. Now, it's really hard to carry a globe around, especially one that shows the level of detail that you want. And so it's so much easier to carry a piece of paper around, a square, regular piece of paper that will show you everything that you need to know or whatever you need to know to get from one place to another. And so instead, we've taken the Earth and we've tried to make it into a flat and square piece of paper. And these pieces of paper are what most of us use when we're thinking about about directions or trying to examine what the Earth is like. The rest of the slideshow, we're going to be talking about maps, how to use them, and what different ones look like. Most of the tools that you can find on a map can be summed up by an acronym known as TODALS, TODALS. And most maps have most of these things. Not every map has all of them. Some of them are assumed that you know, some of them the map maker does not think is necessary. And so let's look at each one of these things, what it is and why it's important. So the first one is the title. The title, it's pretty simple what that is. That's just what the map is called, and it really just tells you what the map is supposed to be of and what it's all about. And so the title are usually really simple things like North America, if it's a map of North America, or Minnesota, if it's a map of Minnesota, or the world, it could be called if it's an entire world map. Okay, now let's move on to orientation. Orientation is what we talked about before with the compass rose. Okay, the compass rose is going to show you which way is north, and then once you know which way north is, you can find east, south, and west with all the tricks that we talked about before. Okay, so this one's really, really important. Seems like it's not so important because most maps show it moving or show north at the top of the page or moving up. Up is north. Well, that's not the way it always has to be. It can be a completely different way, and that could completely change your view of the world. So you need to find that compass rose and see which way is north to really understand what it looks like on the globe. Okay. Now, the next thing in totals is the D, that is the date. The date is important because things change over time. Erosion and, the Earth's forces can change the height of mountains, can change the path of rivers, can change all kinds of things about the Earth. And things like wars and agreements and all that kind of stuff can change the lines that humans have made, the political lines, the border between Canada and the United States, the border between Minnesota and Iowa. Okay, these all can change over time, so the date is important to know. The author is also important because you want to make sure that it's not someone who is biased, who is on a particular side of an argument over a piece of land, and you also want to make sure that they are a good map maker, that there's someone that you trust, that you think they actually did a good job of it. Okay, the second to last one is legend, and the legend, also known many times as the key, shows you all of the symbols that are made on the map, and I can go ahead and circle the legend for you. Here it's called a key, okay? But it shows you all of the symbols that are used on the map and what they mean. So on this map with this legend, a small tree would show a park on the map. A G, a red and white G, would show you where a gas station is. The fire would show you where a campground is. That weird little diamond black line shows a railroad, and the blue line shows a road. If you didn't know this, you might think that a blue line meant a river, and then you could be really, really confused about how you're going to get from one place to another with all those rivers and no roads. All right, so let's look at the last one. The last one is the scale. And the scale is another tricky one, and it can often be overlooked. But a scale looks like this. Okay, and a scale shows you how many miles an inch or a centimeter or a small area or a small measurement counts for on each map. So if you look at a map and it says 1 inch equals 585 miles, you measure that out, and you can measure the exact distance from one city to another. You can measure that the distance from Minneapolis, well, let's say on this one, okay, 1 inch is 585 miles. And if the distance from Minneapolis to Omaha, Nebraska is about 2 inches, okay, that means that you're going to be looking at 1,170 miles, and you know that you're going to have to drive about 1,170 miles to get from Minneapolis to Omaha. And so it tells you the distance on a map because some maps are zoomed way, way in, and 1 inch could equal, like on this bottom one, 1 inch only equals 20 miles, and some are zoomed way, way out, and 1 inch could mean, like on the top one, 1,485 miles. So you've got to know and understand the scale to ever be able to tell the distance between two cities, two items, anything like that. Study this map to better understand the parts of a physical map. Take some time now to write out your answer for question number 7. Let's look at an example of the totals. If we look at this map, we will start off with the T, and the T is for the title. And this map, you can see, doesn't have a title anywhere. So what might we call this map? Well, that's pretty simple. It's a map of the United States, so we could say U SA, and that would be our title. Then we have to move on to O, and O is the orientation. Remember, when you're looking for orientation, you're looking for that compass rose that shows you north, south, east, west. Again, this map doesn't have it. Some maps don't have everything that we're looking for. They assume you know on this one that north is up. So we'd have to draw in our own compass rose, which I'll do down towards the bottom right. And I'll remember, never, ever smoke weed. Okay. Now moving on to D. D is the date, and we can find the date right here, 2000. Then we can move on to A, the author, and the author is right next to the date, and that is John Farley. Then we move on to L. L is the legend. The legend is right here. It shows you that all the states that are yellow make up the South. All the states that are blue make up the West. All the states that are orange make up the Northeast. And all the states that are pink make up the Midwest. This is an example of a map that shows us what the different regions are of the United States. And then we move on to our scale, and there is no scale on this one. It's hard to make up your own scale, so if there is no scale on a map, you're just going to have to write it's not there. You can see there are many different types of maps, and a lot of them are mixed maps that show a lot of these different things. But if we look at kind of the main categories of maps, we're going to find that they are physical maps, political maps, and then special purpose maps. Physical maps, they show you what the land actually looks like. So they'll show natural features like mountains and rivers and things like that. Okay, and it also shows you elevation, so how high it is above sea level. And it'll do that often by showing you different colors. So a darker color may be a lower elevation, and a lighter color, closer to red, closer to orange, might be a higher elevation. And you'll be able to see that on the legend or the key on whatever map you're working with. The second type of map is a political map. A political map shows everything that humans have created, basically. And so it's showing you where are the lines that humans have created to make separate states and to make separate countries and things like that. So it mostly shows you the borders of a country or a state or the world. Special purpose maps, they show you some sort of information about the area. So almost every map is really a special purpose map. A special purpose map can be, a street map. It shows you the roads and how to get from place to place. It can be like a map that shows you how to get around a place. Like, for example, the Minnesota Zoo. If you go there, they offer to give you a map, and it shows you every trail and how you get from seeing this animal to seeing this animal to wherever you want to go in the zoo. Another type of special purpose map that you'll see as the example that I have on here is an election map. You've all seen those election years when it shows you this map and the states are either red or blue. They're red if they voted Republican, and they're blue if they voted Democrat generally. But again, that's information you can find in the legend. This map is a good example of a physical map. Now, it also has some of the political stuff in it. As you can see, it has the borders in it. But if you look at it, the main focus of this map is to show you the rivers and lakes and the mountains and elevation and things like that. You can see down here, if you look at the legend, it kind of tells you everything you need to know about the map. And it even includes the scale here. All right, but it shows you, so the different colors of water is how deep that water is. The different colors of land shows you how high up in the air it goes, how high the elevation is above sea level. Okay, and then these borders, it even shows you that the darker red line is for a country border and the thinner red line is for a state border. And then this one even shows you, which you'll use later on in your map packets, that the different size dots means a different sized population of cities that it shows. So a bigger, darker dot is going to have a bigger population. So you can look at it, kind of understand this physical map. Really, it's interesting if you don't understand the elevation part to kind of look at the Rocky Mountains, because you can see it goes from low and green here in Minnesota, and it gets higher and higher and higher until you hit those mountains, which are like bright red. Okay, so take a moment to look at this map. Here's an example of the political map. I'm not going to point out very much about this because this is one of your questions on your notes. You're going to look at question 8 and try and fill out the TODALS as well as you can from this map. Remember, not every map has everything from the TODALS, and so you have to decide, does it have it, and what is the information that you get from each of these things. Now here's an example of one of those special purpose maps that we talked about earlier, and this is an election map. So it's showing you that all of the states that are blue voted for Hillary Clinton, and all of the states that are red voted primarily for Donald Trump. This is an election map. Now there are tons and tons of different maps out there, but you can see the purpose of this map isn't to show you where all of the states are. Some of the states aren't even labeled on here, but it's to show you which of these states voted for which candidate in the presidential election. Now you're going to take some time to answer your last question, question number 9, and write down as many as you can think of special purpose maps. Maps that show you something else that are trying to show you something else other than the states, the countries, what the land looks like, anything else.